Hello, Bernardo from Robotics Group. I would like to introduce to you the RGi Mini Advanced Wireless Controller. This device is one of the most advanced controllers on the market. We'll start by showing you the power input section. This has got a switching power supply, which is going to run very efficient. This produces 6 volts at 3 amps. 2 amps are used for the servos, so you need to power your servos on that automatically. Then we use the 6 volts to power the individual 3.3 and the 5 volt regulators for the board, for the radio and processor and stuff. And we have about a half amp left over for you that is available in the user header output here. So you'll have 3.3, 5 and 6 volts available to you. Next we go to a dual high power motor controller with current sensing, precision current sensing, limiting, soft start programmability, and input protection and freewheeling diodes available. This device can handle easily 10 amps, 12 amps. On top of that, we have a 20 MIPS processor handling all the communications and firmware. We have a 5 input 10-bit A to D with input protection and filtering and switchable power. The 5 volts is available in the center pin here, and it can be turned on and off remotely. So when you put sensors like IR sensors, ultrasonic sensors, or whatever kind of sensor, you will be able to turn off the power and therefore save a lot of the wasted power. Here we have a 4-port RC servo controller, and again it's got 6 volts in the center pin, which is programmable with this FET here. Again, for when you want to go to sleep, you want to turn off all these things so you go into very low power mode. We have an init switch here that when you press that and power up at the same time, it will put the module, assuming you're using the Wi-Fi module, it will put it into a known state. Here we can put a ZigBee radio with up to a 5-mile range capability, or we can put a wireless Wi-Fi radio in here for your networking capabilities. We have a light output that is a PWM with a 7 amp capability. We can switch it on and off, or we can program it anywhere from 0 to 255 steps, and therefore we can dim lights for your robot. Very useful. Here we have a unique port here, which is called camera power. Camera power is unique in the sense that you can program the voltage that it puts out. So if you're using a webcam that uses 5 volts, you will put that at 5 volts, select the jumper for 5 volts. If you're using a camera, a standard video camera and a video transmitter that runs on 12 volts, you will switch that to 12 volts, and then you can turn it on and off again for power management. And when you want to put the module to sleep, you will turn all these things off and it goes into a very low power mode. We have high voltage FET drivers, so the unit is very efficient, and plenty of capacitors to give you a nice smooth 5 volt and 3.3 volts without any noise and spikes. And that's about it. Thank you. I'm going to show you how simple it is to drive 2 high power motors with the Mini Advanced Wireless Controller. First of all, we have connected 2 pretty high power motors to the Mini Advanced Wireless Controller and a battery. Now these motors require huge amounts of current to start, so we have programmed a soft start feature, and therefore we'll be able to drive those with no problem. Now what we need to do is we need to go to the DSC system controller, which is the software that is included with the system. We go to the setup tab and we make sure that we have the right IP address for the Wi-Fi setup that we have here. And in this case is 95. Down here you see it says offline. When I connect this, it should connect to, there you go, it's connected. Now we can come over here and we see some data is already flowing here. All we have to do from this point on is turn the motor slider, and you notice motor 1 is going. Down here you're getting a real-time feed of the 12 volts, which is the battery, and the current, and that's real time. Now we're going to go with the second motor, and we're going to start that one too. Now these are pretty high power motors, and this board can drive them with no problem. You can see the amount of power, and that's all it takes to drive these motors with this mini board. Pretty straightforward, nothing to it. I'm going to show you how simple it is to drive an RC servo, standard RC servo with our mini advanced wireless controller. We have connected one of the servos to servo 1, which would be pin 1. We can drive 4 servos with this board. The next thing we need to do, we need to come to our DSC system software, and we need to go to the mapper and make sure that we have everything mapped correctly. Here in the title we see servo 1, servo 2, 3, and 4, and they have been mapped to the variable servo and index 1, 2, 3, 4. So that's how we control the individual servos. The next thing we need to do is we need to go to the setup and make sure we have the right IP address for the Wi-Fi network, and this should do it. We should be logged in and it says online. Next thing to do is go to the control section, and you can see here those are the labels that we put in there: 1, 2, 3, 4, the 4 servos. And all we have to do is now move. Oh, notice it's not moving. Why is that? That's because the power on the servos is programmable remotely, and that is used for power management when you're trying to conserve power and go to sleep. You don't want that power to be wasted. So all we have to do is come over here, and we have programmed this button to turn the power on, and you notice the servo went to a location. Now we can do this. We can move the slider and the servo will follow it. Again, we can turn off the power to the servo, and it doesn't matter where you put it. Okay? It's that simple. And this could be controlled from anywhere in the world or at great distances. I want to show you this time how simple it is to make any kind of analog voltage measurement on the mini advanced wireless controller. All we have to do is basically connect the sensor to the board, any of the 5 inputs, and in this case I have attached a battery to pin 1 on the header, 1 of 5 analog inputs. In there we have a 10-bit A to D. This time I'm going to use the terminal. All you have to do say is get pin 1. That will give us the raw value, a 10-bit raw value of the battery voltage. If I want to convert that to a voltage, I basically say get pin dot voltage 1 for pin 1. Send that out, and there it is, 1.582. It's as simple as that. Again, any sensor can be connected to that simply. This time I'm going to show you how simple it is to connect an IR sensor to the mini advanced wireless controller. It basically does all the computation and translation 2 inches all automatically. Let me show you how simple it is. We go to the terminal program, and all we have to say is get pin dot IR for IR sensor connected to pin 1, and we get 14.2 roughly. Now let me measure that for you. Here we have the target, and there it is, roughly 14.2. It's that simple. Everything is happening automatically. Now I'm going to show you something else. We can go to the mapper, and here we can connect and give it a title, IR sensor 1. We call variable pin.ir index 1, which would be for sensor 1. And now we're going to tell it to stream auto update, and the update is 10 times a second, and that number should appear down here. Okay, there it is. You can see it actually happening there. Now I can come over here and move the target closer, farther, and that's it. It's that simple. I'm going to show you the 2 programmable outputs that we have on the mini advanced wireless controller. Output number 1 would be for the webcam, and that output is selectable between 5 volts out and 12 volts. 5 volts would be for a webcam, 12 volts would be for a standard video camera and a video transmitter. Now each output has the capability of 7 amps. Let me show you how simple it is to control these outputs. We go to the setup once again in our control software. We select the proper IP, we connect, we verify that it is connected down here, and we are. Now we have programmed 2 buttons to do this for us. All we have to do is send the command and it turns the power on to the camera. We can also turn the lights on, as you can see. And again, the lights is a special thing. The lights is also a PWM. So we can come over here and actually send a value to the PWM variable, and we can control the intensity. Let me turn this off so you can see it. Here we can control the intensity. Now how do we do that? Well, simple. We go to the mapper and we can see that we have a label, lights on and off. That is connected to PWM variable. It's a toggle, which means it's going to toggle between 0 and 255, and that would be in the button section. Now I can come over here and I can show you how I can send the command by typing it. If I say set cam.power to 1, I will be able to turn that output. As you can see, it came on. If we say 0, it turns it off. Now if I want to control the PWM, I can say set PWM space 0, and it should go to the off state, and this would be your light, or 255. Oops, I typed something bad in there. 255, and there is on, or any number in between. 128 would be half intensity. That's all it takes to control those programmable outputs.